Good day, folks. This is PreCalc Appendix A2. After this section, you will be able to add, subtract, and multiply polynomials, find special products of polynomials, factor polynomials using special products, and factor trinomials, factor by grouping, and evaluate using function notation and substitution. Really what it comes down to, this is a rehash of your Algebra 2 factoring skills. Just make sure you practice this stuff, because the more you practice, the easier these things become. Now, polynomials and factoring, adding, subtracting, multiplying polynomials. A polynomial in X is an expression that can be written in the form a n x to the nth plus a n minus 1 x to the n minus 1 plus, and we go on, a to the 1 x plus a to the naught, where n is the non-negative integer. Well, n's a non-negative integer, and an is never 0. So a n to the 1 all the way down to a1 and a naught are real numbers called coefficients. Now keep in mind the degree of the polynomial is the highest powered exponent, n. So this is the degree of our polynomial right here. And an is the leading coefficient when the polynomial is in standard form. Standard form of polynomial written with powers of x in decreasing order, just like we have here with our general form of the polynomial. Now, a monomial, it has a one-term polynomial. A binomial is a 2 terms, and trinomial is a 3 terms, and these terms are separated by add and subtract signs. To add or subtract polynomials, you combine or add or subtract like terms. Like terms have the same variable raised to the same power. So, in example 1, adding and subtracting polynomials. I'd like you to turn off the video, do A and B of example 1, and then check your solution. Go ahead and do that now. Okay, welcome back. I hope things went well with you. The first one, we have 2x cubed, and x cubed is 3x cubed. Negative 3x squared plus 2x squared is negative x squared. I got 4x minus 5x, and that's going to give me a negative x. That's 4 minus 5 is negative 1, and negative 1 plus 3 is 2. Now in B, now in example 1b, we're looking at 4x squared minus 2x cubed. Now, when this is going on, I got 4x squared, 2x cubed combining, but I also got this negative sign. So I'm just going to rewrite the second one and take the opposite of everything inside and distribute that. So I'm going to get that going. I got 4x squared, 3x minus 4, and I got negative 2x cubed, negative x squared plus x minus 2. Now I'm going to combine like terms. I got negative 2x cubed as my leading term there, and then I've got negative x squared and 4x squared. That's where 3x squared comes from. And I got 3x and x, that's 4x, and negative 4 and negative 2 is negative 6. Now, as we expand the product of two polynomials, working with FOIL, using the distributive property, we can do it this way. We can go 3x times 4x minus 5, 2 times 4x minus 5, and then distribute 3x, which is 12x squared minus 15x, and 8x minus 5. Now I combine like terms, my inner and outer terms, and I can get this, 12x squared minus 7x minus 10. Keep in mind, FOIL is a shortcut. It's a mnemonic device for us to have a shortcut for distributive property. If you look at this, your first, outside, inside, last, so your first was 12x squared. You know, it's 3x times 4x. Your outsides is negative 15x. Your inside is 8x, and your last is negative 10. Well, gosh, this looks the same, and we combine like terms, and we can get the same product. But keep in mind, FOIL is a shortcut. Generally, I don't talk or write this down. I just, I use this to help me, and I know that the outside and the inside will always combine to be that middle term. So keep that in mind as we're going. FOIL's the shortcut. Now, when we're multiplying something more than monomials together, binomials and a monomial, or two binomials. We've got to multiply. There are several little tricks, or methods I should say, shouldn't say tricks, methods that allow us to do this. Now, multiplying polynomials in vertical form. Arrange polynomials in standard form, one on top of each other, so they're arranged. These are the two I'm multiplying in example 2. We're going to align terms vertically, so they're in the same precedence or order, so we got the powers going. Multiply each term of one polynomial by every term of the other. And then we're going to combine like terms. So the first thing I'm going to do, I'm going to take x squared and multiply x squared times x squared times negative 4x, x squared times 3. So I got that. X squared, x to the fourth, x squared minus 4x cubed, x squared plus 3x. Then I'm going to do the same thing with 4x. 4x cubed minus 16x squared plus 12x. And that's what's going on our next line. And our last one is 5x squared minus 20x plus 15. 5x squared minus 20x plus 15. Now, I'm going to combine terms together. Notice how I lined them up. So my order, I had the same power lined up so I can just add vertically. So I've got 4x, I got 0x cubed, I got 3, 5, that's 8, it's negative 8x squared. I've got negative 8x because it's 12 plus negative 20, and I got 15. I don't need that 0 there, so I'm just going to finally write it this way. And that's my product of x squared minus 4x plus 3 and x squared plus 4x plus 5. Now there's a couple other different ways you could probably multiply trinomials. There's a lattice structure you could use, but this is a pretty slick way just to keep track of everything and keep everything organized. Special products, special binomial products. Let u and v be real numbers, variables, or algebraic expressions. Product of a sum and a difference. Well, you've done this. You've got a sum of a difference. This is the uv and uv. U and v are the same values, and this is the sum. This is the difference. Product of the sum of the difference, u squared minus v squared. In order to recognize that you got a product of the sum and difference, you can see this, that these are two perfect squares, and be able to break it down into these two factors. Now, square of a sum. Well, this is a perfect square, of a binomial, and you can see this pattern. You can break it down into factors that look like this. Square of a difference. Same idea of the plus, but it's a minus, but it's got a minus plus situation. Now, the cube of a sum and the cube of a difference are ones that we really have to pay special attention to. uv, the cube of the sum, we've got u cubed, then uv, u squared, v, then uv squared, and v cubed. But notice how we're working down. U was 3, 2, 1, and v wasn't there, and then 0, and then v wasn't there, so it's 0, 1, 2, 3. But we have 1s in front and in back, for the leading coefficients, and 3s here. Now, this is assuming we have variables here. But if we have numbers, you can adjust it with numbers, or better yet, really leading coefficients with variables like 3x or 2x or 5 you can put in with u and v. The cube of the difference. Now, if you look at that, the cube of the difference, there's a negative sign on between the leading term and the second term, and there's a negative sign on the last term. So with that change, everything else is the same with that pattern of 0v, 3u, u is 2 squared, and v is 1, and it works its way down, and if u works its way down, v works its way up. Now, using special products. Use the special products we just looked at up here, and we're going to use the pattern. When I say use the pattern here, I'm talking about you're using the cube of a sum or cube of a difference, and oh gosh, it's a cube of a difference here. Okay, and this one's the square of a difference. Okay, and this one, we're just going to do the product of the sum and difference. So if I'm going to do the product of the sum and difference, I'm just going to go 9x squared minus 64. Okay. Now, did I have to use that pattern? Nope, I didn't. I could have gone first outside, inside, last, and got her done. I can do the same thing here on this one. Okay, but because I'm using the special products that I have the square of the difference, I know it's going to be 5y minus 4 5y times 5y. The first is going to come out because that's square of the difference. And it's going to be 25y squared. And then I'm going to get negative 20 and negative 20. That's where the negative 40 are 2 times u and v multiplied together. And then I'm just going to have v multiplied by itself, which is 16. The one that I'm concerned about here, when I've taken the u minus v, so u is 2x and v is 3y, and I'm cubing it. The pattern that I'm using is u cubed minus 3u squared v plus 3uv squared minus v cubed. So now if I kind of recall that pattern, I can just take 2x and cube it, and I'm just going to put things in where we see them. So 2x is cubed, okay, minus 2x squared times 3y, because now 3y is in there, plus 2x times 3y squared minus 3y cubed. Now after I got everything placed, I'm just going to go for it and get it done. I've got 8x cubed minus 4x squared times 9, which is 36x squared y. I've got 2 times 9 times 3, 2754x y squared minus 27y cubed. Now, I'm really doing that just to make sure that I've written down the right things for you guys in notes, but it doesn't hurt for you to see the evaluation either. I hope this is going well with the special binomial products. And now we got some other structures that we need to visit with factoring polynomials using special products. Now, factoring the polynomial, writing a polynomial is the product of 2 or more polynomial factors. That's what you're doing when you're factoring. In this appendix, factor polynomials to a lesser degree with integer coefficients. This is important. They're going to be integer coefficients. Okay. Prime polynomial is a polynomial that cannot be factored using integer coefficients. A polynomial is completely factored if it is written as a product of its prime factors. Here are the steps. Factor common factors from each term using distributive property. Recognize and expand the expanded form of the 5 special binomial products. We just went through the 5. Use factor pairs if it is not one of the 5 special binomial products. If there are 4 terms, try grouping. Well, that's kind of like the big hint. Okay. Here I've got 2 in everything, and I got an x at least in everything, so I'm going to factor a 2x out of each thing. 2x out of here is, now I put a 2x out front, and I've got x squared left, 2x out, I've got an x left, 2x out, I've got negative 3. So I've factored this down, and as far as being able to come up with something that like 1 and 3 that I'd multiply together and be able to come up with an x in the middle, that's not factorable without me doing the quadratic formula. So I'm done with this right now. Okay. Here, I got u cubed v and u v cubed. Well, there's a u and a v on each of them, so I'm going to pull them out. And I'm going to end up with that as my factors. So I've just removed the common factors. Now the factoring the difference of 2 squares. Now, well, we've done the difference of 2 squares, some more practice, and we're still doing that practice with the 5. Okay, the difference of 2 squares. I've got a difference. Okay, now 1 is plus, 1 is minus in the difference of 2 squares, and you can put it forward or back, but this is the square, if you notice if they're perfect squares. So 5x minus 6 and 5x plus 6. Now keep in mind, if this was a plus sign, I could not do this. Okay, and the next one, it looks weird, like we have, something we haven't seen before, but I got a perfect square here and a perfect square here. Okay, so I got a difference of 2 squares. I've got 2x minus y plus 3, and I've got 2x plus y plus 3 again. Now, I can expand these a little bit if I want to, if they were going to combine, but because of the x and y's, they won't, but it could look like this as my solution. A perfect square trinomial. Now, being able to recognize it's important. I've got a u squared, 2uv, v squared. I've got perfect square as a leading term, and when I take the square roots and I multiply them together and double it, I get the middle term. So that's where I get 3x plus 1, 3x plus 1. So that's 3x plus 1 squared. So I'm going to write it as a perfect square. You do example 6b. Okay, let's see how you did. These are perfect squares, And when I get the 3 and the 2, I multiply them together, and the x and the y, they're there. I multiply the 3 by, the sixth result of that product of the square roots of the first and last term, and I get 12. So that should work, and this should be my product, my factors to make that product. And I'm looking at 2x minus 3y squared. In the sum and difference of the two cubes, notice the pattern of the signs. Notice this pattern, plus, plus. Notice when this one's minus, this is minus. Okay, and this is minus when there's a plus up front, and this is a plus when this is minus up front. So those two kind of flip-flop, but then there's a plus at the end. This is used several times throughout the entire year. So start paying attention to some of these patterns because they're pretty darn helpful. We use this in working with trig identities. You'll have this type of combination to deal with. Now, here in example 7, we are going to consider using one of these two models. But this is a subtract, so we're going to use the cube of a difference, or difference of two cubes. And this is one cube, this is the other. And remember, it's x cubed and 4 cubed. 4 cubed, 64. So I'm going to pull out the difference of two cubes pattern, and I'm put x and 4 in for u and v. So x is here for u, v, 4 is there for v, and the same down here, x and 4, x and 4. And now I just finish the factoring, so I now have quantity x minus 4 times the quantity x squared plus 4x plus 16. Now, in a like manner, I'm going to do the same thing in b. I'm recognizing it's the sum of two cubes. So I've got 2x here, and I got 3 there. So that's where 2x cubed and 3 cubed. And now, again, the pattern, I'm going to put that in. Make sure we've got that going on. I'm not going to put them in this time because now you're familiar with what I'm doing. This is 2x. This is 3, so that's my leading, 2x and 3. That's going to be 4x squared. Somebody forgot to put a parenthesis in here, so we'll get that going. Not sure why I have that extra 2 there, so we're going to dump that out. But now we got 2x plus 3 and 4x squared minus 6x plus 9, and that's our solution for this example. Factoring trinomials, okay? So we got factors of A, factors of C. You've seen this before. I want you to go after A and B, see how you do. Go ahead, turn it off, and give it a try. Now remember, when you're doing this, you're looking for a number, two numbers actually, that will multiply to be negative 14, but add to be 5. And the reason why I said negative 14, you have a plus and a minus. Okay, so two numbers that will multiply to be 14 are 2 and 7. And if one of them is negative, it could be 5. So which one's negative is the smaller one because it's a positive 5. So I've got x plus 7, the larger one's positive, and x minus 2. Got it factored. Same idea here, two numbers that will multiply to be 30, but add to be 11. But now, because it's positive 30 here, they are both either positive or negative. So let's see what it is. And because of this value here, they're both negative. So it's got to be 6 and 5. And we got 4 sets of examples left. Let's look at example 9, factoring a trinomial with leading coefficient not 1. So now I got to play with my factors. I looked at the factors of 35, 1 and 35, 3 and 7. 5 and 7. And I look at the factors of 12, which is 1 and 12, 2 and 6, 3 and 4. A set of those combinations is going to help me. Now if I go 5 and 7 and 3 and 4, and generally what I do, I write down 5x and 7x just to see what's going on, and then I place in either 3 and 4, 1 and 12, 2 and 6 to see where it is. But because this is a small number, I'm just going to go with 5 and 7, 3 and 4 right off the bat as I go through. And I got 5 and 7 going on. Now I got 35 here, but I'm going to use the 3 and 4. Now if I put 3 here, I got 21. If I put 4 here, I got 20. What I'm going to be able to get done. So when I'm looking at this, I'm just going to pop in the 3, pop in the 4. I got 21, I got 20. I got to make the 3 negative so it's bigger, negative 21 because of the negative. 3 times 4, negative 3 times 4 is me, negative 12. You go ahead and do B and see how it works out for you. Okay, again, I got 5x and 2x. That's going to be 10. Breaking apart, I've got 2 and 6, 3 and 4. But 2 and 6, I got 30 and 4. That's not going to be it. And 18 and 10, that's not going to be helpful. So 3 and 4 are it that I'm going to use, and they're all positive because of these plus signs. Now, factoring the trinomial again in x and y, hey, it's exactly what we just did, except we have x and y in our factors. So I got 3x and x. I'm going to have y's over here, and it looks like 2y and y. How I'm going to operate with 2y and y. So I've got 6xy and xy, and they both have to be negative because this is positive, this is negative, and that's where I'm making those decisions. Same idea here in example 10. 6x squared plus 11xy minus 10y squared. I've got a 3x and a 2x and a 5y and a 2y maybe. Let's check those out and see what's going on. And remember, it could have been 6x and x. I'm just going for the middle just as a guess right now, just to get these things going. And then I'm looking at this, and I've got 5, and 5 times 3 is 15. 2 times 2 is 4. So I'm going to have them split because this is negative, and this has got to be negative and positive. And their combination's got to be positive 11xy. Now, factoring by grouping, you know, just notice what's going on here. I've got 3x cubed and x squared, 6x and negative 2. I can pull out an x squared out of this. And I can pull a negative 2, excuse me, out of this. So that's what I did. I pulled out an x squared, pulled out a negative 2. Now this is 3x plus 1, and this is 3x plus 1. So I got x squared minus 2 times quantity 3x plus 1. And I've got it factored. Your turn. Give it a try. See how you do. Turn it off and go. Okay, so I'm going to factor out here a 2a and here a b on each one. Now I got c minus d. And that's the important thing. Once I factor them out, these and this factor, it's got to be the same. So now I've got 2a plus b if I extract the quantity c minus d from each side, or each member there. Now, function notation is substituting values other than x. All I really want you to do and recognize is we have f of x, g of x, p of x, and k of x up here. And I want to go f of negative 1. So I'm going to have you plug in negative 1 for x. G of 5 squared. Now this is kind of an interesting thing because g of anything is 2. So you got to be thinking about that. And I've got k times 2x minus 1. And here I've got 2x minus 1. I'm going to put in for x there. And I'm just evaluating these. So here it is. I'm going to put negative 1 in. I'm just going to kind of get to the meat of the order. I put negative 1 in where I saw x, and I evaluate. So I get 6. Here, because it's a constant, I'm just going to square the 2, and I'm going to get 4. On this next one, I've got k, which is 2 minus x squared. So I'm plugging in for wherever I see x here, 2x minus 1. So 2x minus 1 went in for x squared. And now I just evaluate and combine like terms, so simplification. So 2 minus 4x squared minus 4x plus 1. I got to distribute the negative. I'm here, and now this is going to be positive 1 at the end. Oops. And I'm going to do the same thing here. Why don't you do d and get your k done? Okay, so turn it off, and you go ahead and do d. Okay, so 4 minus x went in for x squared. Okay, so I got FOIL. Get this out, distribute my negative, and combine my 2 with my negative 16. That's where negative 14 came from, and I'm done. Now, I'm going to do the same thing with f of x plus 2. So I got f of x plus 2. Every place I see x plus 2, x, I'm going to put in x plus 2. So that's what I'm doing. X plus 2 goes in, and I evaluate, and I'm getting that 3x squared plus 4x plus 4 minus 2x minus 4 plus 1, and I come up with my final answer. Now, we're doing this to have you recognize, first of all, we're going to get work done here, and we're going to use that work over here in G. Okay, so F is f of x plus h. So wherever I see x, I'm going to put in x plus h. So we've got x plus h squared minus 2x plus h plus 1. I evaluate, and I'm here. I'm going to distribute the 3 and distribute the 2 and combine like terms. So I've got 3x squared, 6hx plus 3h squared minus 2x minus 2h plus 1. Now I'm going to get the terms together if I got any, and it doesn't look like anything is going to combine, so that's it. Well, I'm going to use this here, right here. So I've got that going. I just moved it over because I've already done that work. I am going to take minus f of x, which is minus 3x minus 2x plus 1, okay? And then I've got this all over h. So now I just evaluate. So I've got 6hx, and that's negative 3x squared, knocks each other out. 6hx I start out with. I got negative 2x here, so that's plus 2, so that's going to be gone. And I've got this minus 1, that'll be gone too, so that I end up with 6hx plus 3h squared minus 2h all over h. Well, I can factor an h out, so I'm going to. So I'm going to factor out an h. So now I've got 6x plus 3h minus 2 on top, and that's my final solution. Okay. Remember, the more difficult the algebra, more cumbersome it seems, you just got to make sure you're showing your work. And I neglected to finish something over here. I think I forgot to combine these two here, 12x and negative 2x. So I apologize for that. Those people that were rolling their eyes at me, you know, that happens. So let's move on and let's get that going to our assignment, because we are done with working on factoring. So PreCalc A2 assignment, page 789, 1 through 7 odd, 9 to 39 multiples of 3, so you can go 9, 12, 15, 18, and so forth, all the way up to 39. 41 to 44, 45 to 55 are odds, 56, and then 60 to 66, again, multiples of 3, 69 to 73 odd, and 75 to 90 multiples of 3. Hey, I hope things are going well, folks. Remember, read your Schoology syllabus stuff for Chapter P. I'm having you hand in assignments, 2 assignments each time you're in class. And remember, you're correcting online, you're asking questions in class, and then we're handing them in. I hope things are going well. We'll talk to you soon.